Today I'll solve the 17th challenge on Ethernaut called recovery. A contract creator has built a very simple token factory contract. Anyone can create new tokens with ease. After deploying the first token contract, the creator sent 0.001 Ether to obtain more tokens. They have since lost the contract address. Recover the 0.001 Ether from the lost contract address. I'll copy this code over to my code editor. I already deployed this challenge, but if you have not done so, then click on this button. I copied the code from Ethernaut over to my code editor. In this challenge, there is a factory contract that deploys tokens. Someone has deployed a token contract and then sent 0.001 Ether to it. However, they have lost the address of the token contract, and our challenge is to recover this 0.001 Ether, and we don't know where the address of the token is. So there are two goals in this challenge. Find the address of the token contract and then recover 0.001 Ether from it. Let's take a look at the contracts. Contract recovery. This is a factory contract and it deploys the simple token contract. Scrolling down, simple token is the token contract and 0.001 Ether was sent. I'll click on the keyword payable to figure out how Ether was sent into this contract and how we might be able to withdraw from it. Ether is sent to this token contract by calling the function receive, so directly sending Ether to this contract will update the balance of the token. Clicking on the payable keyword again, I can see that it is highlighted in the function destroy. This function can be called by anyone, and when it is called, it calls the function self-destruct. Recall that self-destruct will delete this contract, and then whatever Ether that is locked in this contract will be sent to the address of the two specified here. So once we find the address of this token contract, we can call the function destroy to recover the 0.001 Ether. So the main goal of this challenge will be to find the address of this token contract. Let's scroll back up to the factory contract. Contract recovery. There are two ways to get the address of the token contract. We can go to Etherscan and then look for all the transactions that call in to generate tokens, and then from there dig deeper, find the address of the simple token. Another way to find the address of the simple token contract is that we can compute it. There's a formula to calculate the address of the contract. Using that formula, we can calculate the address of the token that was deployed, and then from there, recover the 0.001 Ether. But what is this formula? How do we calculate the address of the contracts? To find the answer, I searched on ethereum.stackexchange.com. How is an address of an Ethereum contract computed? Scrolling down, I can find the answer. The address of an Ethereum contract address is deterministically computed from the address of its creator, the sender, and how many transactions the creator has sent, the nonce. The sender and the nonce are encoded and then hashed. Here is the example. I'll copy these two code over to my code editor. Inside my code editor, I'm going to write a helper contract that computes the address of the token contracts that were deployed. I'll name this contract dev function recover, and then it's going to take in the address of the sender. Here the sender will be the address of the recovery contract. This function will be external. Here returns address. And then paste the code that I copied over from ethereum.stackexchange.com. I'll change this origin to sender and likewise over here. And then I formatted the code so that we don't have to scroll left and right to analyze this code. This is how the address using the 0th nonce is computed, and below it, this is how the address using nonce 1 is calculated. The only difference between this code and this code is the numbers that you see over here and the number that you see over here. I'll guess that when generate token was called to deploy the token contract, nonce 1 was used. So I'll remove this code, and then here I'll say address ADDR is equal to this, and then return this ADDR. Next, I'll copy this code to Remix, and then we'll call the function recover and get the address of the token. Okay, I've copied the code over from my code editor to Remix, compile the contract, and then make sure that I don't select the testnet. I'll just select Remix VM, and then deploy the dev contract. Scroll down, and then we'll need to call recover, and for the input, we'll need to pass in the address of the factory contract. To do that, I'm back inside Ethernaut. I'll type F12 and pop open my browser console, and then get the address of the instance. Next, I'll paste it inside the function recover, and then call the function recover. Let's check that the address that we computed is indeed a contract and it has 0.001 Ether. So I'm inside Etherscan and I'll paste the address that I just copied. And notice that this contract has 0.001 Ether. And click on contract. It has some unverified code. So this is indeed a contract with 0.001 Ether. Now that we found the lost contract address, the last step is to call the function destroy. So to do that, I'll copy this simple token contract and then paste it inside Remix. Hit Ctrl S, make sure that the contract compiles. And next, I'll select the Goerli testnet. So click on injected provider. Make sure that it is connected to the Goerli testnet. And then what we're going to do is load the simple token interface at the address of the lost contract. I'll copy this, and then back inside Remix, I'll paste the address, and then open the contract, and then we'll call the function destroy. Let's send the Ether back to our account. So I'll copy the address of our account, paste it here, call destroy. Confirm the transaction, and the transaction was successful. Let's check that this contract no longer has Ether. Inside Etherscan, this is the address of the token contract, and it has 0.001 Ether. If I refresh this page, this should turn to 0, and it does. Okay, the last step to complete this challenge is to submit the instance. Once you beat the level, you'll see the button change to go to the next level.